Hello, everyone, and welcome to today's webinar. This is Weaveworks Deploy, Troubleshoot, and Control Kubernetes-powered containers and microservices on AWS, hosted jointly by AWS and Weaveworks. My name is Christopher Hine. I'm a partner solutions architect with AWS. I'll be your host speaker and moderator for today's webinar. So the first thing that we want to talk about today is some of the industry shifts that we're actually seeing within the cloud as well as within the container ecosystem as it currently stands. And the first, there's three key components that are really crucial to talk about. The first one is elasticity. So, and this really represents the ability to actually scale up and scale down and really pay for only what you need within the cloud. The next thing that's really important to actually talk about is the agility that you're going to get out of using the cloud as well as deploying with containers. And so this is being able to iterate quickly, deploy and fail fast, and kind of taking your development workloads and pushing that through to test to prod in minutes versus hours and weeks. And then the last piece that's really important that's to talk about is high availability. And this means that we're building out infrastructure that's both highly available. It also has auto healing capabilities and audit and management techniques built into how that whole infrastructure is set up, as well as your architecture. And this doesn't just rely on that, it also dives into the physical infrastructure, being able to span more than one location and physical distribution across the world. So this is where we enter in the world of containers. And so for those of you that are new to containers, container is a method of packaging up an operating system as well as an application and all the dependencies that you need to work with that application. And you're being able to take that and deploy it into resource isolated processes that are managed by things like C groups, as well as you can take that application package, because it's a declarative script, you can take that and distribute it to anywhere. So it's infrastructure agnostic, etc. The key benefits that you're actually going to get out of doing this is being able to provide a consistent and efficient version control and deployment of your actual applications. And what we're actually seeing with this is that's helping companies like those of you that are on the line to actually accelerate to the cloud. And it's really reducing that friction to transforming your business to be more digitally focused. And so what does this actually mean for you? So you're now able to actually take that application or that declarative script and you're able to make smaller, more frequent changes to both the infrastructure as well as the applications. And you're able to do that with a higher level of confidence because you're able to run it exactly the same as you would on your laptop as you do in the cloud. So no longer do you have to worry about version control issues or package management issues on your infrastructure. Everything is written out and deployed through in a single declarative script. And that's really streamlining that development and deployment processes. Now, what does this mean in terms of AWS? So in terms of AWS, it gives you the ability to get the full spectrum of AWS services that help you build microservices and containerized applications. So these are services like integrating with DynamoDB and RDS for databases, SQS for queuing, Kinesis for streaming, using CloudFormation templates to do management of your infrastructure, as well as things like CloudWatch for monitoring and logging and having a consistent space for all of that stuff, as well as Elasticsearch for analyzing those logs or even some of the application data that you have going into it. And our services span across compute, networking, analytics, mobile, and also containers to basically just help you all be more productive as application developers and operations teams. And the big thing that's important to remember here is we continue to add new capabilities into this at an accelerating pace. So just last year alone, we launched 1,017 new services and features that were significant. Moving on from that, we have a global footprint, and that means that you're able to deploy your containerized applications into any of our 43 availability zones, and those span across our 16 geographic regions. And we have an additional 3 regions that are expected to come online throughout 2017 and 2018. Continuing that forward, you get the benefits of cloud security. And so these are things like AWS that has achieved a number of internationally recognized certifications and accreditations that enable customers to achieve their specific security and regulatory objectives. And so these things are tools like CloudTrail or KMS, which is our key management service, and Inspector, which really enable the customers to meet all of those objectives. And the last piece is our partner ecosystem. And our partner ecosystem is a rapidly growing ecosystem of customers. Specifically in the container space, we have things from networking as well as security and CI/CD, and then we dive a layer lower into orchestration, management, and kind of the operating systems under the hood for running these containerized applications. And so that's where we have companies like Weave. And so Weaveworks is an APN partner, and they build tools and services to help you run containers on Kubernetes on AWS. And their tools give you the full view of the infrastructure at any given moment. And so that's things from being able to dive into the AWS infrastructure, such as Amazon DynamoDB or RDS, or and be able to see and monitor that external traffic as well as the internal traffic between your own containers. And so Stuart here, who's on the line from Weaveworks, has a story to tell and share with you about how they use AWS and Kubernetes to make their deployments smooth and easily reproducible.
Thanks, Chris. So first I'd like to tell you a little bit about Weaveworks and our mission. Weaveworks is a 3-year-old startup. We're at the Series B stage and are funded by Accel Partners and GV. We're fundamentally an open source company. You can find our projects on GitHub at github/Weaveworks. Please start some projects. We'd love to see people starting those and helping us share what we're doing. We're best known for our Docker networking project, the somewhat eponymously named Weave, but we've also been running a cloud service for just over 2 years using Docker, Kubernetes and Prometheus, to name a few of the key technologies we're using. We've learned a lot from running this service on containerized infrastructure, and we've devised some tools and adapted a methodology that's given us a mission, and we call this GitOps. This is a label we gave to our approach to managing container infrastructure, and we found that many other people in the community are adopting a similar approach. GitOps is a methodology that combines practices like continuous integration pipelines, concepts like observability, and methods of control, so developer teams can spend more time hacking, or as they prefer their boss to think, creating business value. I'll talk a bit more about GitOps shortly, but first I'd like to tell you a short and slightly scary story for Halloween. This is a true story about things going horribly wrong and how we recovered from it. I mentioned that we're predominantly an open source company, but we also run a service. Weave Cloud is the service, and it's a software as a service product that automates deployments of and offers visualization and monitoring for containerized applications. Here's a screen showing some of our deployment workflows and graphs. Here's a monitoring screen. I'm sure you've probably all seen a time series graph before. And here's a visualization of Weave Cloud in Weave Cloud, which is very Inception. So aside from a plug, what I'm really trying to show you is that it's a real product. Here's an overview of the architecture. It's a system of systems, it's microservices, it's what we call cloud native. It uses a variety of Amazon services for infrastructure and for storage. You can see that there's monitoring and management. We're storing data in RDS. We're using DynamoDB, Amazon S3, SQS, and so on and so on. And it's a complex distributed system. So how are we using containers? We're using containers to package those services. Each of the applications is deployed using automation tooling we wrote, and indeed that's part of Weave Cloud, to a container orchestrator. That container orchestrator is Kubernetes. And Kubernetes is kind of a policy engine. We describe what we want to run, and it makes it happen. If something fails, it starts a new one. Because our packages and containers are immutable, we can promote them unchanged from a development or staging environment to a production environment, which makes it very easy for us to predict what kind of runtime is going to run in production. We have confidence that whatever we've tested is the thing that actually runs. We don't rebuild each time. So here's a quick summary. It's cloud native. It runs on Kubernetes, and it uses lots of Amazon services, which is fine. It's awesome. It worked like clockwork until the day we deleted the production system accidentally, inadvertently creating the perfect example of why manual processes can go wrong. Luckily, not all of it was deleted, but it's the kind of situation where the on-call team have nightmares about it. But our Weave engineers are not prone to panicking. And this is not a Weave engineer. The team have a plan, and we're doing what we can to rebuild the system from scratch. They have a process. While one of the team is getting the comms plan together, another of the team has broken the glass on the big red metaphorical button. So we're restoring the system. This looks promising. Hopefully it won't take too long. Maybe I won't do this bit in real time. Systems restored. So it took 45 minutes. 45 minutes doesn't seem too bad. How is this possible? Let's remind ourselves of what's going on under the hood here. The system is quite a complex system, as I said. We're using Amazon EC2 instances. To reinstall the production environment from scratch, we need to install Kubernetes, and we need to start deploying applications and start data services. It's possible to do this in our environment in 45 minutes because we use declarative infrastructure tools. Tools that declare infrastructure as code, things like Kubernetes, Docker, Terraform. In the declarative approach, we specify the end state of the infrastructure we want, and then some software makes it happen. The state is declared in files. The files are stored in Git. We're using Amazon services and infrastructure, so we already have an underlying resource that will service our demand for deploying all of this infrastructure that we've described in files. And because we've automated everything, we can run the whole process without needing manual and thus error-prone intervention. We don't have to wait for humans to confirm that certain bits and pieces are running. We call this methodology GitOps. GitOps is evolution of DevOps. In DevOps, we say config is code. Code must be version controlled, and therefore config must be version controlled too. In GitOps, we take this a step further and assert that everything should be version controlled. Configuration, code, monitoring dashboard descriptions, network policy, etc., etc. And if we can describe it, we can use a declarative tool to automate it. If we can automate it, we can then perform other operations on it. Let's look and see what a standard CI pipeline will look like. If we're going to deploy application from infrastructure to some infrastructure, we're going to start with a code repository. We're going to run a CI, continuous integration pipeline build. It's going to build the code, it's going to run some tests, and because we're smart engineers, the tests are all going to go green. The artifact is produced at the end of the build process and stored in a repository somewhere where our deployment process can take a copy of it and apply it to the infrastructure. So far, so good. What's different about the GitOps pipeline? Oh, faster. The GitOps pipeline starts in a very similar way. Code repository, CI pipeline. This time it's an image repository because we're going to build one image in a container. And then our deployment automator is a slight different process to the previous deployment process. The automator is going to make a change to the configuration repo. The configuration repo has a set of declarative configuration files telling us what state the application or the infrastructure is in. In this case, it's going to tell us that a Kubernetes manifest describing an application needs a new version of the application that's just been built in the pipeline. And then a separate process we call the deployment synchronizer. It's a slightly more simple process, and all it does is it runs inside the infrastructure, and it looks at the external configuration repo, sees if any changes should be applied, and applies it to the orchestrator. So we've separated out the change to the infrastructure and stored it in a configuration repository, just indicating where CI, continuous integration, and continuous delivery are separated. And these are the types of change we can use to trigger a deployment. So we can change the code, we can trigger a manual deployment, or we can change configuration files in the repo directly. The deployment synchronizer will still apply each of the changes as they're deployed, as they're changed in the repository. We can even send an update hint from the CI pipeline to the automator to say, get ready, you're going to need to do something in the near future. So let's compare those two pipelines. In the first, we would expect to expose a cluster API endpoint. The CI system is going to need credentials if it's going to make a change to the cluster API. And we only have a single repository where the application state is described. So what's the source of truth? If you've lost the cluster, if you accidentally deleted your cluster, you can't go and check the cluster for the state that it's supposed to be in. The CI system itself isn't a good example of where to maintain the state because it's a transient system. And you may have made more changes to the application in the various repositories that your code is stored in by then. In the GitOps pipeline, we've got the option of running the agent inside the cluster itself. When the cluster is up, the agent runs, it modifies the state of the cluster. It can sit inside the cluster and ask for state from the configuration repository that sits outside. So the credentials for operating on the API of the cluster itself, or indeed for the repository in which the config is stored, never leave the cluster. We have a separate configuration repo, and this means that our source of truth is entirely independent. So let me say that again. Because we're declaring our desired state in an external location, we've got options on where to run the agent that automates it. We don't need to expose an API endpoint to a CI system or expose the cluster credentials. And when we separate the application and the infrastructure configuration, the declared state is independent of the cluster. So if you accidentally delete your cluster, you can recover from this without needing to re-establish some state from a location that's no longer existent. Git's ideal as a source of truth. It's independent of the orchestrator, obviously, but it's also resilient. You can have multiple copies of the state stored in different locations. And it contains the desired state of the whole system. The desired state's interesting because if it's different to the actual state, we can alert on it. In our system operating Weave Cloud, we even do that. We have a set of configuration alerts that fire in Slack that tell us when the cluster is different to the state we expect it to be in. What are the other benefits of taking this approach? Any developer can use GitHub-like workflows to do operations tasks. There's issues, pull requests, and reviews. You can join the team and be productive immediately if you're familiar with their standard workflow a developer's used to. And we can we can audit all of the changes to infrastructure. All the modifications to infrastructure can be validated, and of course they can be automated. This is important. If you have strict requirements for control of a production environment, for example, a banking and finance applications, you can now restrict direct access to a cluster to only automated processes. You can audit all of the changes and you can validate them. Here's a quick summary. So we deleted in production environment. I don't recommend you do this at home. We are able to do this because we've used software-defined infrastructure and data services. Those things are described, declared, version controlled, and automated. Our mean time to recovery is low because of this, even in the case of a complete loss of environment. Because we automated everything, our engineers spend more time developing and less time operating infrastructure. GitOps is our label, but this is an emerging practice. It's being adopted in particular by people who are operating containerized infrastructure when we started blogging about GitOps on the Weaveworks blog, we had a number of people contact us on Twitter, for example, Atlassian, saying, we've done this too, but they gave it a different label. So we know that this is a practice that is well suited to container infrastructure and also one that the community is adopting. Okay, I'm done. Let's look at the questions. Chris?
Yeah, thanks. Now we're going to transition into questions or our live Q&A. Stuart, I think there's one for you. So the automator seems really interesting. How does it actually handle destructive changes?
Destructive changes, so we would assume that means removing a piece of infrastructure that's been there already. The automator's not going to operate on something if it doesn't exist anymore. If we delete something from the repository that's under management by the automator, it's not going to operate on it anymore. So in a sense, the automator doesn't really have any knowledge of this. A destructive change would typically be a manual change that we'd say, make a change to the Git repository, and then neither the synchronizer or automator will act on that again. In the case of something being removed from the cluster that you're operating on, unexpectedly, the automator will restore that to the cluster each time, rather the synchronizer will restore that to the cluster each time.
Awesome. So it's going to keep the actual consistent state, and if you need to actually delete something, you can delete something manually separate from the actual automator process. But
yeah,
correct. Cool.
Yes.
Awesome. So how does actually GitOps fit? How does GitOps fit into the compliance requirements for things? I think you mentioned it a little bit, but if you could talk a little bit more about that with like banking applications and so on and so forth.
Yes, sure. So it's fairly typical in more strictly managed environments for development teams to not have direct access to production environments, and for a specific team in operations to have full control over when deployments happen. And sometimes we hear concerns about how automation will change this. I don't think it does if you're adopting a GitOps-like methodology, because control over the production environment is really configured to be operated from this separate configuration repo where our infrastructure and application is described. And because it's a separate repository or set of repositories, we can put a different set of controls around that. And that means in the case of an ops team could restrict access to that repository such that the development team who want to make changes can only submit those changes through pull requests, because the pipeline itself doesn't have to be fully automatic. It can be configured to queue up deployments. This would be the difference between continuous deployment and continuous delivery, where the final say is in continuous delivery, that methodology says we'll make changes manually when it suits us to do so, but we'll use automation to affect the change. So a single button push or a single command is issued, and automation actually makes all of the changes itself. So I think for compliance requirements, the separation of concerns will align almost exactly with standard practices. We're just suggesting that the Git operations methodology is the best way forwards for this.
Awesome. Okay, it looks like we have some more questions. So what measures have you implemented since this happened?
Measures as in since we broke the deployment?
Yeah, since the deployment broke. It looks like it's asking about fallback clusters, any duplicate clusters, and what's going to make the recovery time faster next time.
I think less manual changes is probably the best description. The change here was really an accident, and it was an inadvertent change that it's fairly easy for an engineer to make if they don't really want to. I'm trying not to go into details here, but the cluster infrastructure itself is more resilient as we've grown and matured as a business. We've added more capability in that department, but fundamentally the process hasn't really changed. Less fingers, more automation is the way forwards.
Fantastic. Okay. Did you guys see or have you experienced any drawbacks with the move to a fully automated process?
Not so much. I think the industry has been moving towards greater automation over time, and this is really a reflection of that evolution. The process of adopting automation is typically slightly painful to start with, but the benefits are that we have a more reliable deployment process and that we spend less time worrying about releases. Releases are now things that don't take very much time at all. In our staging environment, it's fully automated. If code gets merged to master, then it's deployed. The results are deployed to that environment. We currently manage deployments to the production environment, partially for business reasons and partially for organizational reasons. We just want to be organized about when we move features and groups of features together into production.
Awesome. Okay. How do you actually maintain the versioning between multiple containers and configurations within the same application? So this would be deploying the same pod but a different configuration. How do you run them in parallel? Is there some sort of blue-green setup?
So applications, we don't have many examples where we have the same component deployed in different configurations. In the case of the environments, the configuration is in the same repository, but it's in separate directories for each environment. So there's a duplicate in effect.
Okay, cool. Let's see. I saw Grafana and FluentD in your diagram. Can you give some details about the metrics you value and the alerting regime you put in place, and how do you derive operational insights from the metrics you collect?
Okay, sure. We have a methodology which one of our engineers referred to as RED, which refers to sort of attempts to refer to the again increasingly emergent properties of that the industry is sort of adopting for this kind of infrastructure. We care about monitoring requests per second, we care about error rates, and we care about latency. The infrastructure and the application itself can be consuming resources, extremely, a lot of resources. But if the quality of the service, as derived from those three metrics, hasn't actually decreased, then we consider that the user experience is being maintained. We may make changes to optimize the infrastructure, but it's really about focus on the user.
Awesome. Okay. How are you managing logs or restoring deploys? Is there a faster way for this, or do you offload this totally to the user's responsibility?
Logs for the infrastructure, we are using a logging service, so the log data for our own containerized applications and infrastructure that's backing Weave Cloud is being shipped off the machines as fast as possible. I don't know what that means about restoring deploys. We are most of these application services themselves are stateless. They're operating on back-end services, so we can roll back using the tooling that we built relatively easily. it's a button push, for example, in most of the services that if we needed a single change to roll that back. And that's a case of making a change in the Git repository, describe the manifest, which version we want, and then the synchronizer does the job of making the change. I'm not sure if I can answer the fast way to do this. And in the case of users who are using functionality in Weave Cloud, then their own applications, we're not a log data collection service, so that's up to the user.
Awesome. Okay, let's see. Does Prometheus live within your Kubernetes cluster? And if so, how do you guys handle high availability and resilience or redundancy within terms of the monitoring of it?
Good question. So Prometheus itself, our Prometheus does live within the cluster, but also we have Prometheus that's configured to send data to Prometheus acts as an agent, has a remote write functionality. So rather than storing the data locally in its own container or a volume, it's sending the data over the network to an API that looks exactly like Prometheus. This is in fact a feature of Weave Cloud. So the production environment sends data to the production environment, staging environment, and the staging environment sends data to both environments as well. So we have duplicate copies of that data for our own purposes, but also the user data is stored in exactly the same way. So the data that we receive from users in our production environment is collected from Prometheus agents that are configured to use remote write. And the data itself is actually stored in some of those Amazon services that you saw. So we use DynamoDB, we use S3 to gain redundancy and high availability. It's a data service that does the work for us.
Awesome. Let's see. Sounds like somebody else is using that sort of Git flow or GitOps type of mechanism, and they call it shadow hand. That's pretty cool.
Yeah, I'm not sure if maybe that's a better name. We should call it shadow hand.
Cool. Let's see. Do you have all of your microservices in one Kubernetes cluster or multiple?
A single cluster.
Single cluster. Okay. So if
we have one cluster for each environment, which is simply so that we can destroy the non-production environment independently and operate on that and upgrade versions of the infrastructure itself, of Kubernetes and so on. But all of the infrastructure and apps for the production environment run in single Kubernetes.
Awesome. How is have you guys noticed any drawbacks or experienced any issues doing it that way, besides obviously the one that we already talked about?
I think we've run into I think we've run into the odd Kubernetes bug, but Kubernetes for us has been pretty reliable. It was the subject of some investigation when we started 2 years ago about which direction to take, and we're pretty happy that we picked the right result.
Awesome. Okay. So can you talk just a little bit more in depth into what Weave Cloud provides as well, and what that enables everybody on the line to actually start playing with and experiencing for their own Kubernetes infrastructure?
Love to. So we have a number of separate agents. The 3 slides I showed at the beginning that show the core bits of functionality are deployment automation, where we run a Weave agent. One of the open source projects I referred to is the core of the agent there, and it handles deployment. So as I said, Weave Cloud deploys Weave Cloud, and we've used that tooling for nearly 2 years to do that. So the code itself is pretty robust. The productized version of that in its current form is on a 1.1 release, I think today or tomorrow. It's going to give you a lot of value because you will be able to do deploys that are fire and forget. You commit the change to master in your application. The pipeline will build the process. You make the change when that version is available in the repository in a Kubernetes. Manifest either manually, or you let the agent do that. It can do a fully automatic deploy, or you can do a button push in the UI. When you use the user interface, we can give you time series graphs from the monitoring system that match up to the service you're deploying. It's one of the things that we learned as we were doing deploys ourselves, was that the engineers would sit with a Grafana dashboard open, look at the services that are about to deploy, look at the dry run output, and then deploy the service, and then sit and watch the dashboard and make sure nothing went horribly wrong immediately. So we built that kind of workflow directly into the product. And that's our mission. We're going to try and build more of those types of time-saving, improved comprehension workflows. On comprehension, the Explore functionality is an open source project called Weavescope. It's a visualization tool that looks at connectivity data from the operating system, from the Docker API, from the Kubernetes, from orchestrator, and builds a model of how the application is talking to different components internally to the application and externally outside. So what you see there is that graph of edges and nodes that show you the shape of your application. The idea there is that it should be the diagram that you would draw on the whiteboard if you were trying to debug an incident, or if you were trying to educate a coworker, or maybe even your boss, about what the infrastructure and what your application looked like. It helps you reason about the model you're working, the model of the application you're working on. If it's the same model that you can look at, that's the model that's in your head, and then you can interact with it. You can open a terminal in the browser through to a component if you need to go poke a process and find out what state it's in, look at a log stream, all those kinds of stage one troubleshooting. I need to establish what's happening here. And of course, monitoring and alerts are a fairly standard feature of an operations tool today. We have also co-opted another methodology called OODA, O-O-D-A, the OODA loop, which was originally American Air Force strategists' way of looking at battlefield situations, and it's an anagram. Sorry, not anagram. OODA stands for OODA, stands for Observe, Orient, Decide, Act. And the idea, it's a loop whereby you establish what's happening, you see what's happening, you orient yourself to see how things are connected together, or what the relationship between the circumstances you're in are. And then you make a decision, and then you act on that decision, and you go round and round. And that, we think, maps very neatly to the iterative process for writing, deploying, and debugging software. And so we're trying to enable that capability in Weave Cloud.
Awesome. Okay. And so how does that actually differ from the open source tools, and is there ways that you can actually run Weave Cloud on premise, or even in your own cloud or like account, or how does that work?
So you dropped out for a little bit there, Chris. Could you say again?
Yeah. So I was asking if there's a way that you can actually run Weave Cloud like on premise, or even in your own private cloud account, for example. And how does that differ from the open source tools?
Okay, so the open source tools are sort of the core functionality. So Weaveflux, Weavescope, and Prometheus, and its sister project WeaveCortex, which is the open source SaaS part of the data collection things. You could run all of those parts independent of us. One of the things that we haven't open sourced so far is the integrated user interface over the top of that. We don't have a full standalone offering for on-premise yet that replicates the entire functionality of Weave Cloud. It is on the roadmap, and we can put bits of the open source projects together to give you the basic functionality, so you can get visualization, you can get monitoring, and you can get deployment. but as yet, as we're still developing the joined up workflows that sort of traverse all of these different bits of functionality, those are not available in a standalone product.
Great. Okay. Let's see. Looks like we've got a bunch more questions that came in. This is great. Okay. How did it how did it change your guys' operations teams structure culturally, any sort of thing that went into that with this new automation process?
We have less engineers spending time on ops. We typically have one person who's the designated person for doing operations on a given day, and that rotates between the engineering team. The team it didn't really change how we were doing things because the team set out with the intent of operating with as much automation as possible. We have people in the team who've been SREs at large cloud companies before, so they had brought some of the learnings and the methodology from those environments in, as well as new ideas that we had to do with how containers were fitting into this world.
Great. Okay, that's awesome. Looks like, how do you manage the audit with CI/CD? Are you using Jira or some kind of change management process? Maybe that's GitHub and Git tooling.
So the audit trail for all changes is in Git. So we're not using Jira for that. We are using GitHub for all of our operations as well as for our code development. So we have a load of private repositories, and there are issues, files, and people want to make changes to our infrastructure. They have to submit a PR to do that. So the process is as described in the earlier slides. It's the standard or increasingly common Git workflows that we see developers using.
Perfect. Let's see. Can you dig more into Weave Cortex?
Yes. Okay. So it's open source, so you can go poke there. There's a Slack channel, slack.weave.works, which is our community Slack, and there's a Cortex channel in there if you want to ask questions. It's a public API that looks and behaves exactly the same way as Prometheus does. It contains components of Prometheus and some custom code that we've written to handle high volume ingest of the payloads from a Prometheus agent. It has modifications that allow us to do multi-tenant data storage and a number of integrations for different data backends. If your interest is in operating a Prometheus compatible system for different groups of users, then you're welcome to try Cortex out and help us develop it. There is a small community growing around it that's developing that project.
Awesome. So go check out the Weave Slack channel and check out the open source project, and they can get more information.
Yep.
Cool. Oh, that's an interesting one. So how do you guys actually handle credentials securely? Since everything is managed through Git, are you keeping your secrets in there, or what do you actually do for like config maps and so on?
I don't recall the exact function service product that we're using for some of the services, but services access secrets from within the cluster, and they're not written in Git as far as I know.
Fantastic. All right, it sounds like we probably have time for one more question. So does Weaveworks work on other hybrid approaches, and what does it actually provide there?
I'm not sure what that means.
So does WeaveWork actually, WeaveNet and Weaveworks actually help to build out hybrid cloud on-prem solutions?
Yeah, I suppose. Okay, so WeaveNet acts as a virtual network for Docker containers. So you can configure part of the network to be in the cloud and part of the network to be on-premise. We have a number of talks out there where people have demonstrated using WeaveNet across multiple clouds. We know users are using it to build a network between on-premise and cloud environments. Yeah, it's pretty flexible. It's a decentralized networking component with a mesh network design. So it's pretty resilient.
Fantastic. Okay, on that note, we're going to actually wrap up today's webinar. Thanks.